exercise number 15 matches up with example number 4, where we're talking about inverse functions and how to find those functions algebraically. So the function f of x that it gives us here that we're going to be working with right here, 2x minus 3 all over x plus 1, okay? And we're just going to change that f of x. I know we've been trying to write in functions, but let's just change that to be y equals the same thing. And the reason we're going to do that is because of step 1. Step 1, switch the x and the y. So when you are trying to find the inverse of a function, the first step is to switch the x and the y. So right here, instead of y, I now have x equals, and then instead of 2x minus 3 over x plus 1, I have 2y minus 3 all over y plus 1. And then I want to solve the new equation for y again. So now we're going to go through how you would normally solve this equation for y. And it looks like the first thing I did is I multiplied both sides by y plus 1 to get rid of the denominator. So I end up with x from here, right, down, x times y plus 1. And when I multiplied this side here by y plus 1, it got rid of the denominator and otherwise stayed the same. Then the next step is I distributed this x through the y plus 1, because in order to get y by itself, I need to separate the term y plus 1. And the only way to do this is if I distribute this x through my parentheses. So that leaves me with, sorry, for whatever reason I want to use green here instead. So that leaves me with x times y is xy, and x times 1 is x. So I have xy plus x on this side. Haven't done anything to the other side yet. Now I'm going to subtract my xy's from both sides. And the reason I'm trying to do that is because even though this y, it's xy, this y has an x, I want to try to get everything with the y on the same side. So I'm subtracting xy from both sides so that I get here my 2y is now on the same side as my xy, although it's negative xy over here. Now I want to move everything away from the y's, so I'm going to add this 3 to both sides, so it cancels out with this 3, right? And that gives me x plus 3 here equals 2x minus xy. Now, if you've been working ahead of me, you will notice that in order to get y by itself here, since I have a y here and a y here, I'm going to just factor it out. So I get y times 2 minus x after I factor that y out. And then, since it's multiplying by the whole term 2 minus x, I'm going to simply divide both sides by, let me get rid of these really quick, 2 minus x, right? So if I divide that by 2 minus x, it cancels these two out. And then on the other side, the same thing. I divide x plus 3 over 2 minus x, and that gives me my new function. Y equals x plus 3 over 2 minus x. However, since you may have noticed, since we have a rational number here, we got to look at the denominator, 2 minus x, because that's going to create a restriction on our domain. So it ends up being negative infinity to 2, but can't be equal to 2 because that would create a 0 on the denominator, union with positive 2 to positive infinity so that we don't have 0 on the denominator. So make sure still, you guys, when we're doing our domains, that you take into account any restrictions. So the function, the inverse function of this is in fact a function with a restricted domain.